Hey, welcome back. This time we're going to work with multiplying polynomials. So let's see what we got. So recall again that an exponent, for instance, if you have 3 to the 4th, that just indicates repeated multiplication. So 3 to the 4th is the same as 3 times 3 times 3 times 3. All right? Okay. What we want to do now is kind of multiply these exponential expressions together. So let's say I have 2 cubed times 2 to the 4th. So how would that work? Okay, 2 cubed is 2 times 2 times 2, and then 2 to the 4th is 2 times 2 times 2 times 2. So this, how many 2's do I have? 1, 2, 3, 4, 5, 6, 7 of them. And that kind of suggests a method for doing this quickly. If you look at the exponents on the left, you have 2 to the 3 plus 4. So the exponent 3 plus 4. And then on the right, the exponent is 7. So you kind of see a connection. It has, you're going to add them, right? So if you add 3 plus 4, you get 7. Okay, so if you have x squared times x to the 5th, you could either literally write it out x times x, and then x to the 5th is x times x times x times x times x. And then you could sit there and count them. There's 1, 2, 3, 4, 5, 6, 7 of them, so it would be x to the 7th. But it's much quicker to just say, all right, x to the 2 times x to the 5th is x to the 2 plus 5. And that will be x to the 7th. Okay? So we get this general rule. In general, if you have like bases, so b to the m times b to the n, that'll equal b to the m plus n. Now this won't work if you have different bases. So if you had 3 to the 5th times 2 to the 10th, there's no way to kind of multiply that out with adding the exponents, all right? You're just kind of stuck with what you got. But if the bases are the same, in other words, the bottom numbers, the 3 and the 2, if those were the same, for example, 4 to the 5th times 4 to the 10th, then you're good to go. Here the bases are the same, so it would be 4 to the 5 plus 10, which is 15. Okay. Okay, so it's kind of simple. It's just the hard part is remembering the rule, So problem 1, you have x to the 15 times x to the 3rd. Worst case scenario, you could literally sit there and write out all 18 of them, but it's better just to add the exponents, right? So x to the 15 plus 3, that'll be x to the 18th. And a lot of these, you can do these in your head. You don't necessarily need to even write them out, except for just your notes. So this one is, of course, a little weird because you don't see an exponent on the y factor. And my pen stopped working again. So problem 2, I have y times y to the 14th. Okay, if you don't see an exponent, you just put a 1 there. So it's basically just y to the 1 times y to the 14th, and then you got y to the 1 plus 14, which is 15. Okay. If you have more, it's the same game. You're just adding all the exponents. So it would be x to the 16th. 7 plus 5 is 12, plus 4 is 16. Okay. That'll be 3 to the 17th. So you don't have to, sit there and multiply those out and get a number without exponents. You just write 3 to the 17th. Okay, so this is the next rule. Question 5 gets us to the next rule. So what happens if you have something like 3 squared cubed? Okay, how do I deal with that? Well, 3 squared cubed, if you just think of it as kind of something cubed, it's 3 squared times 3 squared times 3 squared, right? There's 1, 2, 3 of them being multiplied together. And then in the exponents now, you can add the exponents. So you get 2 plus 2 plus 2, which of course is 6. And we want a shorthand rule to get us from the beginning here to the end here. And the question is, can you see the operation to do with the exponents? And in this case, yeah, it's multiplication, right? So it's 3 to the 2 times 3 is 3 to the 6. So in general, if you see those parentheses, you have something like b to the m raised to the nth power. All you got to do is multiply the exponents. So you get b to the m times n. So in problem number 5, you have 4 to the 7th to the 11th. That'll be just 4 to the 77th power, which is a huge number. Which I doubt our calculator would even want to stomach that number. It would probably freak out. Let's see what the calculator does. 4 to the 77th power. Oh no, it gave you something. 2.28 to the times 10 to the 46. That's a number with 46 digits in it. So it's a big number. Okay. Anyways, more of the same here. We need a calculator for that one. 4 times 17. That'll be 68. So x to the 68th. This one's a little different because of that negative in there, but you don't overthink it, right? So this will be negative 20 to the 3rd and then raised to the 4th power. Okay, so it's basically just negative 20 to the 3 times 4th power, which is negative 20 to the 12th. And that's it. Negative 20 to the 12th. Okay, and now we get another rule. So this rule says if you have a product raised to a power, in general, the rule is you can raise each individual term to that power. So you'd have a to the m and then b to the m. Okay. So for, if you want an example, let's say I have 2x cubed. So I could rewrite that as 2x times 2x times 2x. And then I could kind of collect the 2's together and then collect the x's together. And what do you get? You get 2 cubed times x cubed. So basically the shorthand rule is just to raise each individual factor to the 3rd power. Okay, so for example, on question 8, you have 7z cubed. You could write out 7z times 7z times 7z, and then it'd be 7 times 7 times 7 times z times z times z. It's easier just to put 7 cubed times z cubed. So we'll have 7 to the 3rd power times z to the 3rd power. Let's see if that's good. Okay, so sometimes they want you to multiply out the 7 cubed part. If it's a small number, so back there with number 7, negative 20 raised to the 12th, it's a huge number, don't even bother. But if it's a small number like 7 cubed, they're probably going to want you to multiply that out. So 7 to the 3rd power is 343. So I'll put 343 z cubed. Yeah, there's no real rhyme or reason to it. It's just, if it's smaller, then go ahead and multiply out. Okay. Number 9 is a bit different because of that negative. So last time we kind of ignored the issue with the negative. This time we have to deal with it. It's in our face, so to speak. So how do I deal with it? Well, you're going to pretend that negative 8 is one of the parts, and then the x is the other part. So you'll take the negative 8 and raise it to the 2nd power, and then you'll have the x and raise that to the 2nd power. And then they want you to multiply that out. So a rule with negatives, if you raise a negative to an even power, it'll become positive. So negative 8 squared is going to be positive, and then 8 squared. So that would be positive 64. Negative times a negative is positive. But in general, if you raise a negative to an even power, it'll turn into a positive. Okay, so we have 64x squared. Okay, so this is a more general version of what we were just doing. And so it's problem 10. The deal is you have 5x cubed squared. So how do I deal with that? It's going to be 5 x cubed times 5x cubed, which is going to be 5 squared times x to the 3 plus 3, which is 6. Okay. So kind of looking for the pattern here, what did I do? I raised the 5 to the second power, and then I multiplied the exponents on the x to third squared. So let me rewrite it. Maybe it'll be more obvious what I did. Okay, so I kind of go 5 squared, and then I think of this as its own term, and I raise that to the second power. So I have x cubed squared. Okay, so the first term will be 25, and then I have to multiply the exponents here, so it'll be x to the 6. Okay, so 25x to the 6. All right, let's try another one. This is question 11. I have negative 4y to the 9th to the 4th. So here I'll raise this negative 4 to the 4th, and then you raise to the y to the 9th to the 4th. So I have negative 4 to the 4th, and then y to the 9th to the 4th. So I can figure out negative 4th to the 4th. A negative to the 4th power, that's an even power. 4 is divisible by 2. So it'll end up being positive, and then 4 to the 4th is 256. And then y to the 9th to the 4th, that you multiply the exponents, so that'll be 36. To decide on the calculator what button to push, so I have 4. The button to push is the x to the y button there on the left. And then you can put in your exponent. It'll look, you could basically, I think you could type in the caret key. Yeah, and that'll work as well. Anyways, 256 y to the 36. And here's another. In general, with these kind of problems, if you have, so in general, what's kind of going on here, you have a times b to some power m, and then raised to an nth power. The way I think through it is kind of just, all right, the a doesn't, you don't see an exponent, so you just pretend that's a 1. And then what you're doing is multiplying exponents. So it's kind of like a distribution. So you have a to the n times b to the m times n. Okay, so maybe some examples are in order. Let's say I have 3x cubed to the 4th power. That'll be 3 to the, and there's an exponent of 1 on the 3, so 3 to the 4th, 4 times 1 is 4. And then x to the 4 times 3 is 12. Okay. Let's say I have 2x to the 11th raised to the 3rd power. That would be 2 cubed x to the 33, right? So that would be x, and they want you to multiply it out when reasonable. So 2 times 2 times 2 is 8. Then the x to the 33. Let's say I have 4x raised to the 2nd power. So the exponent on 4 is 1, the exponent on x is 1, so that would be 4 to the 2 times 1 is 2, and then x to the 2 times 1 is x squared, so that would be 16x squared. Okay. Let's look at number 12. So negative 3y to the 6 cubed. Again, when you have this negative, you kind of have to pretend that negative 3 is one term unto itself. So I'd have negative 3 to the 3rd power, and then y to the 6 times 3, which is 18. Okay. Negative 3 to the 3rd, that will be negative because it's raised to an odd power. And then 3 times 3 is 9, times 3 is 27, y to the 18th. Okay, so negative 27, y to the 18th. And I guess now we get some more rules, multiplying monomials. Okay, so it's monomial times monomial. And the way you do it is to first multiply out the constant terms, or the coefficients. The coefficients are just the numbers in front of the variables. And then secondly, multiply out the variables. And when you multiply out variables, it'll be the like base kind, so you're going to be adding exponents. So really there's only two kind of operations with your exponents. Either you're multiplying the exponents, like in this case, and that's usually when you see parentheses and it's raised to some power on the outside, right? So let me give you a brief synopsis of that. There's two cases. You have the case where you're having like bases, and in those cases you add the exponents. And then there's the multiplication case. So let's say I have a times b to the m, and you raise that on the outside, you raise it to some nth power. In that case, you're multiplying out the exponents, right? Because a really has a first power on it. Those are really the only two cases, a to the m and then b to the m times n. I mean, it gets a little more complicated because they kind of like throw those negatives in at you. But at the end of the day, it's really, am I multiplying the exponents or am I adding the exponents? Okay. Of course, in this case, it would be negative 4 to the third power times x to the 6. So in this case, you're multiplying exponents. And this would be negative 64x to the 6. Okay. So when you're working with multiplying polynomials and you're multiplying variables, the case that you'll be in will be this add exponents case. You're never going to be multiplying the exponents when you're multiplying out polynomials. Okay? These other cases only come when you're multiplying, when you're working with exponential expressions and you're raising monomials to some power. So you just focus in on that first rule of adding the exponents. Okay, so problem 13, we have 6x times 2x. So I'm going to multiply the 6 times the 2, that's 12, and then the x times the x. And what you're doing there is adding the exponents. And again, if you don't see an exponent, the exponent is 1. So you get x to the 1 plus 1, which is 12x squared. What else? Okay, so a lot of these, after a while, you'll be able to do them in your head. 7x times 2x cubed. 7 times 2 is 14, and then we have x times x cubed. And again, the exponent on x is just x to the first power. It's just a 1. So you have 14x to the 1 plus 3 is 4. And it's basically, you do a lot of these in your head. So negative 5 times 2 is negative 10. And then y to the 4 plus 3 is 7. Here, negative 1/2 times negative 1/3 is positive 1/6. And then you get a to the 11th. Again, you're just adding the exponents. 6 times negative 4 times 3. Negative 4 times 3 is negative 12 times 6, I believe, is negative 72. Then you have x to the 5 times x to the 1 times x to the 2. That's 5 plus 1 plus 2. That'll be 8. 5, 6, 7, 8. Okay, so now we're into monomial times polynomial. And I hit the button on my marker again. There we go. And what this comes down to is distribute and then follow the monomial by monomial rule. So you're going to multiply out the constants and then multiply out the variables. So 18, we have 4x times x plus 2. Okay, so you're distributing. That'll be 4x times x plus 4x times 2. The first term, it'll be 4, and then you're adding exponents on the x's. So it'd be x to the 1 plus 1, which is 2, plus 4x times 2 is 8x. So 4x squared plus 8x. Number 19, you have x times x minus 10. So you're going x times x, and then x plus x times negative 10. X times x, add exponents, so you get x to the 1 plus 1 is 2, and then minus 10x. And of course, I typed it in wrong. Oh, I didn't check the answer or something. Okay, great. Some more of the same. Let's try this one, number 21. So we get negative 5y times 4y plus 8. Okay, so it'll be negative 5y times 4y, and then plus negative 5y times 8. Okay, so the first term, negative 5 times 4 is negative 20. Then y times y, add the exponents to get y squared. Then minus 5 times 8 is 40, and you get y. Negative 20y squared minus 40y. And eventually, we hope you can do these in your head. You don't have to write them all out. In the beginning, it's not a bad idea to write them out, though. 20. Let's skip ahead. Okay, so here, monomial times a trinomial. Same idea, though. It's just you have 3 terms to distribute to. So 3y squared times 5y squared minus 9y plus 7. Okay, so that'll be 3y squared times 5y squared, and then plus 3y squared times negative 9y, and then plus 3y squared times 7. And then 3 times 5 is 15, y squared times y squared, add the exponents. 2 plus 2 is 4. Then minus 27 y squared times y, so that would be 2 plus 1 y cubed. Then plus 21 y squared. This is just, you can put the term, the monomial, on either side, and it'll still work out the same. Times 2x, so you're just distributing again. It's not anything different. So it'd be 2x times 4x to the 4th plus 2x times 5x cubed. So 2 times 4 is 8, and then x to the 1st times x to the 4th is x to the 5th. Just add the exponents. Plus 2 times 5 is 10. X to the 1st times x to the 3rd is x to the 4th. It's no big deal. And the 5th plus 10x to the 4th. Same spiel here with the added bonus of the negative sign. So we got what, x squared plus 7x minus 5 times negative 3x. So negative 3x times x squared, and then plus negative 3x times 7x, and then plus negative 3x times negative 5. So it'll be negative 3x cubed minus 21x times x is x squared. Negative negative is positive 15x. So negative 3x to the 3rd minus 21x squared plus 15x. Okay. Oh, more of the same. Okay, so now we're on to binomial by binomial. And you could think of it as distributing one term at a time. So, for example, in problem 28, we'll have x plus 8 times x plus 4. So the way you want to think of it is distributing the x to the binomial first. So it would be like x times x plus 4. And then plus, then you distribute the 8. Okay, so plus 8 times x plus 4. So when you do that, you'll have x times x plus x times 4 plus then 8 times x plus 8 times 4. Okay. So you'll get x squared, x times x is x squared, plus x times 4 is the same as 4 times x, and then plus 8x, and then plus 32. And for these, you have to then kind of watch out. There's sometimes like terms that you have to combine. So here we'll have x squared plus 8, 9, 10, 11, 12x plus 32. Okay, so we'll have x squared plus 12x plus, oops, I lost my x, plus 32. Yeah, and yeah. Okay, let's try this guy. This is number 29. Okay, so I have 2x plus 7 times x plus 6. Okay, so again, you could rewrite it if you want, but I mean, it's really just this. It's 2x times x plus 2x times 6, and then you distribute the other term. So it'll be 7 times x plus 7 times 6. Okay, so 2x times x is 2x squared. 2x times 6 is 12x, and then plus 7x, and then plus 42. And again, you got to combine those two middle terms. 2x squared plus 19x plus 42. Okay, so 2x squared plus 19x plus 42. More the same, and a negative in there. Okay, let's try 32. 32, I have 2x minus 7 times x plus 5. Okay, so first distribute the 2x. So you get 2x times x plus 2x times 5. And then distribute the negative 7. So plus negative 7 times x plus negative 7 times 5. So that'll be 2x times x is x squared. You're just, again, adding the exponents. Plus 5 times 2 is 10x. And then minus 7x, and then minus 35. Combine like terms. We get 2x squared plus 3x minus 35. Got some fractions. You can do this if you want. 33. 1/7 x plus 7 times 5/7 x minus 1. Okay, so first this one, you have 1/7 x times 5/7 x. And then this one plus 1/7 x times negative 1. And then this guy, so plus 7 times 5/7 x. And then this guy, plus 7 times negative 1. Okay, so for the first term, multiply out the constants. So to multiply fractions, you multiply straight across. 1 times 5 is 5. 7 times 7 is 49. And then x times x, adding the exponents, give you x squared. Then minus just 1/7 x. And then plus 35/7. So remember, 7 is the same as 7 over 1. Multiply straight across. 7 times 5 is 35. 1 times 7 is 7. X, and then minus 7. Then combine like terms if there are any. So we have 5/49 x squared plus 34/7 x minus 7. Hopefully that'll do it. 5/49 x squared plus 34/7 x and minus 7. So no big deal there. Okay, multiplying now a monomial times a trinomial. So it's just distribution on steroids, right? So instead of distributing the x to 2 terms, you distribute it to the x squared, the 6x, and then the 4, like this. So you go this times, and then plus that times that, and then this times this, and then you have to do the 2. Okay, so let me show you. So first, x times x squared plus x times 6x plus x times 4. And then you have to distribute the 2 to all 3 terms. Okay, so that'd be 2 times x squared plus 2 times 6x plus 2 times 4. Okay, x times x squared is x cubed plus x times 6x is 6x squared plus x times 4 is 4x plus 2x squared plus 12x plus 8. And then combine like terms, so I have x cubed 6 plus 8x squared plus 4 plus 12 is 16x, and then plus 8. So I have x cubed plus 8x squared plus 16x plus 8. Right, and that's just more of the same. Let's get some funny variables in there. Maybe we'll come back to that one. It's a quadnomial, I guess. Let's try this one, 38. So I have x minus 1/2 times 6x cubed minus 4x squared plus 3x minus 8. So again, it's just distribute. So I have 6x cubed times x minus, I guess I should put the x times plus x times negative 4x squared plus x times 3x plus x times negative 8. And then distribute the negative 1/2. And if you want to, you can write it in the vertical format to align the variables. So they have a negative, well, all right, I'll just do it as it is. Negative 1/2, so it's plus negative 1/2 times 6x cubed plus negative 1/2 times negative 4x squared plus negative 1/2 times 3x plus negative 1/2 times negative 8. Okay, clean it up a bit. So 6x cubed times x is going to give me 6x to the 4th. And then x times negative 4x squared is minus 4x squared times x is x cubed. Plus 3x times x is x squared minus 8 times x. And then I got some fraction multiplication. 1/2 times 6 is just 3. And then there's a negative, so it would be negative 3x cubed. Negative 1/2 times negative 4 is plus 2x squared. And then negative 1/2 times 3x is negative 3/2 x. 3 is the same as 3 over 1, and then multiply straight across. And then finally, negative 1/2 times negative 8 is plus 4. Combine like terms, so I just have the 6x to the 4th, and then the cubes. So minus 4x cubed minus 3x cubed is minus 7x cubed, and then the squares. 3 plus 2 of those, it's 5 of them. And then the x terms, okay, so I need a common denominator. So I can pretend 8 is 8 over 1. Then multiply top and bottom by 2. So that would give me negative 16 over 2x plus negative 3 over 2x is negative 19 over 2x. And then finally plus 4. Okay. Trinomial times trinomial, so now you just have 3 distributions. So it's 39, I have x squared plus 7x minus 9 times x squared plus 3x minus 5. Okie dokie. So first the x squares. So I'll have x squared times x squared plus x squared times 3x plus x squared times negative 5. And then the 7x, so plus 7x times x squared plus 7x times 3x plus 7x times negative 5. That was from this, this, and this. And then finally the 9. Let's give myself a little more room. So negative 9 times x squared plus negative 9 times 3x. It's this one. And then plus negative 9 times negative 5. That's from the third one. So you should have 9 terms altogether. Okay, multiply out. So add the exponents. X to the 4th plus 3x cubed minus 5x squared plus 7x cubed plus 21x squared minus 35x minus 9x squared minus 27x plus 45. Start combining like terms. So you have x to the 4th, then the cubes, 3 plus 7. Okay, so plus 10x cubes. And then the x squares, negative 5 plus 21 is 16. Minus 9 is plus 7 x squared. And then we get 35 plus 20 minus 20, negative 35 minus 27. 3, 4, minus 62x, and then plus 45. Okay, so let's just distribute 3 times. Combine like terms. And then, okay, so in the history of mathematics, they were studying geometric figures before they ever really got to algebra. And it'll talk about in the book, maybe it was a different book I was reading the other day, but in the history of math, they start with geometry before they get to algebra. So this problem kind of connects geometry to algebra. And what we're doing is kind of expressing the area of a rectangle in terms of variables. So we have this picture cut into pieces. So this length is 2x, this length is x, this length is 2, and then this is 6. Okay. Part A, they want to express the area of the large rectangle as the product of 2 binomials. Okay. Okay, so what you do is kind of, you can get the length and the width, right? So the overall length of this side is just the x and then plus the 2. So that's one binomial. So the area is equal to the length times the width, and then the width is going to just be the 2x plus 6. So the area is the length times width, or in this case, I guess the base times the height or whatever. So x plus 2 times 2x plus 6 basically is the area. So you've turned, this geometry into algebra, which is a very powerful development for the history of mankind. A very powerful development for mankind. Okay. Then they want you to just individually go and find the sum of the area of these 4 rectangles. And to get the area of those 4 rectangles, it's just length times width. So this first rectangle here will be 2x times 2. And then plus this rectangle will be 2x times x. And then this rectangle is 6 times x. And then finally, this rectangle is 6 times 2. Okay, so that would be 4x plus 2x squared plus 6x plus 12. And then combining like terms and writing the order and descending degree of exponents. So 2x squared, and then 4 plus 6 is 10x, and then plus 12 is the sum. And then they want you to show that part A and part B are the same. So you'll multiply out part A, and hopefully you'll get part B, right? So you have to do double distribution. So that'd be x times 2x plus x times 6 plus 2 times 2x plus 2 times 6. And then that'll be 2x squared plus 6x plus 4x plus 12. Combine like terms, that will be 2x squared plus 10x plus 12. And sure enough, they're the same. Okay, so they put 2x plus 6 first, but that's okay. 3 times 2 is the same as 2 times 3 kind of idea. So you can put x plus 2 times 2x plus 6. Or you could put 2x plus 6 times x plus 2. They're the same. Okay, and then they're kind of doing the distribution the way I first introduced it, but ultimately it's C. Okay. So to write it the way they're doing it, let me rewrite it with x plus 2 second. So they have 2x plus 6 and then times x plus 2, and then they want you to distribute first the 2x to the x plus 2, right? So it'll look like this, and then plus distribute the 6 to the x plus 2. And then individually distribute, which is, kind of, we killed 2 birds with 1 stone. But it's the same answer. It'll be C. Okay. So, barring the issue that there's multiple ways of introducing this, we will just think of it as double distribution without this extra intermediate step that the book is kind of harping on. So you don't necessarily need this, but in order to answer that question, yeah, you kind of need to be able to pull that off, I guess. Obviously, part B isn't right because they're missing so they went 2x times x and then 6 times 2. They're missing the 2x times x. They're missing the 2x times 2 and the 6 times x. The first one would have to be 2x times x plus 2, not just the 2 times 2. That one's a mess. So yeah, it's C. Okay. So hopefully that helps. Let me do it the way they were doing it. So they have 2x plus 6 times x plus 2. Oh, I see. The only difference between mine and theirs, I mean, it's the same thing, right? It's 2x times the binomials, 2x times the x plus 2. But really what that is just, 2x times the x times 2x times 2. So 2x times the x plus 2x times the 2, which is what you would get in the second step if you were just to distribute. So I'm just trying to tell you that what we're doing is exactly the same. And then plus, on the other case, you have to distribute the 6 to the x plus 2. But that's the same as saying, all right, 6 times x plus 6 times 2, right? Which is the same as distributing here. It's just I'm hoping to save you one step of work. So 2x times x is 2x squared, plus 2x times 2 is 4x, plus 6x plus 12. And that would be 2x squared plus 10x plus 12. With my problem, I did it in reverse order, but it won't make a difference because of the commutative law of multiplication. 3 times 2 is the same as 2 times 3. right? But it'll look different, right? So if you do it their way, it'd be x times, this whole thing, x times 2x plus 6, and then plus 2 times that whole thing. So 2 times 2x plus 6. And then you have to distribute these. So 2x times x, or x times 2x, plus x times 6, and then plus 2 times 2x, plus 2 times 6. And if you look above, that's exactly this right here. Okay, it's just I skipped this. I saved you a step. We didn't have to do this x times the binomial and then 2 times the binomial. It's just now it comes up in the story problem where they're kind of forcing you to do this extra step, which I didn't really make clear. Okay, so hopefully that's clear. Hopefully in general they'll never ask us to do that again. But anyways, I hope that helps as usual, and we shall see you next time.